Hello everyone! Today we will be discussing over how to solve triangles using law of sines and its ambiguous case. Let's get started! So what exactly is law of sines? It defines the ratio of sides of a triangle and their respective sine angles are equivalent to each other. This means that one interior angle of a triangle to its opposite side or the side the angle is facing is a ratio, and that all three of these ratios in a triangle are the same or equivalent to each other. So for example, let's take angle C, and we get the side the angle is facing to, which is this is side C, and this is angle C. This will become a ratio, these two. Same with angle B to side B and angle A to side A. Let's imagine angle C and side C may be the longest measurements of the triangle, while angle A and side A may be the smallest. But the angle and side ratio they have with one relationship is the same with the other relationship. Law of sines formula is written like this, and the fractions can be flipped over. Law of sines can be used for finding any other triangle that is not a right angle, which are acute and obtuse triangles, as right triangles typically use the Pythagorean theorem. Law of sines can be used when the given includes two angles and one side, or two sides and a non-included angle. What is a non-included angle? So first, let's define what an included angle is. Suppose we have a triangle and the given sides are this side and this side. This will be the included angle because this angle is in between the two given sides. Therefore, it is included. So when we are doing law of sines, a non-included angle would be this side given, or this angle given, or this angle given. Two angles and one side can also be used as the given in law of sines. It can be this angle or this angle and this side given. Examples of situations where law of sines should be used in solving for triangles. This case is the two angles and one side. And this case is the non-included angle and the two sides. If the given in solving triangles include three sides or two sides and an included angle, then use the law of sines, which will be in another lesson. A triangle with only three angles given are impossible to solve further because there is nothing to show as sides. Let us now start to solve triangles. Solve the triangle if angle A equals 70 degrees, angle B equals 55 degrees, and side A equals 12 centimeters. This is angle A, this is angle B, and this is side B. We are looking for angle C, side B, and side C. Okay. The formula we're going to use is the law of sines, which is sine angle A over side A equals sine angle B over side B equals sine angle C over side C. Okay. If we replace everything, with the given, this will be sine over 70 degrees, sine over 55 degrees, and 12 centimeters. Let us first solve for angle C. So what we're going to do is add 70 plus 55, which will be 125, and we are going to minus it by 180 because all the rule says that all angles of a triangle add up to 180. So the difference of 180 and 125 is 55 degrees. Therefore, sine C equals 55 degrees. We're going to replace that here. Now what we're going to do now is to find side B. And by doing that, we cross multiply these two. So our equation now will be 12 sine 55 over sine 70. So now we are going to use a calculator to solve this, which in 10.460067, so on. If we round it off to the hundredths, we get B equals 10.46 centimeters. So now since we solved that, we can replace 10.46.
Now we're going to solve for side C.
We just cross multiply, so it's going to be 10.46 multiplied by sine angle 55 degrees, and we divide it by sine 55 degrees, which will also result to 10.46067, and so on. And once again, if we round it off to the nearest hundredths, it's 10.46 centimeters. And we have solved for this triangle. Let's move on to another example. Solve the triangle if angle A equals 35 degrees, angle B equals 25 degrees, and side C equals 68 meters. This is going to be angle A, this is going to be angle B, and this is side C. We are looking for side B, side A, and angle C. We're going to write the formula. Sine angle A for side A equals sine angle B over side B, and sine angle C over side C. We're going to replace these with the given. Sine 35, sine 25, and 68 meters. So let's first solve for angle C. 35 plus 25 equals 60. 180 minus 60 is equals to 120. So angle C equals 120 degrees. So now we're going to solve for side B, and how we're going to do this is by cross multiplying. Sine 25 multiplied by 68 over sine 120. If we calculate this using a calculator, we would result to 33.18383 and so on. If we round this off to hundredths if we round this off to the nearest hundredths, we get side B equals 33.18 meters. Now we're going to erase everything. But we're actually going to keep this because we'll be needing this later. 33.18. So lastly, we're going to solve for side A. So we're going to cross multiply once again. Sine 35
multiplied by actually
how we're going to multiply this is the result of side B, but not rounded off yet. So we're going to put 33.18383 and so on. And we're going to and
divide
it by sine 25 will be given 45.03701. But if we round it off to the nearest hundredths, the final answer would be 45.04 meters. Now, sometimes in law of sines, we need to use the ambiguous case. When the given to solve for a triangle are two sides and a non-included angle, we use a method called ambiguous case. This is because an angle in between two sides are not given. Therefore, sometimes it can result to multiple triangle solutions. Sometimes usually being two, but it can also result to only one or none at all. This is why we check if there are more possibilities in ambiguous case. More on that later. Let's try doing a problem involving ambiguous case. Solve the triangle if angle A equals 60 degrees, A equals 9 inches, and side C equals 10 inches. We're going to get this formula. Sine angle A is over side A equals sine angle B is side B, and sine angle C is side C. So we're going to replace all of this with a given. Sine 60 is 9 inches and 10 inches. So first, let's focus on trying to get angle C. Sine angle 60 over 9 is sine angle C over 10. Now we're going to cross multiply. 10 and sine 60 over 9 equals sine C. So now we're going to transfer sine C here and make it an arc sine. So sine, it will be written like this. And if we calculate this using a calculator, C will become C will result to 74.20683 and so on. Round it off and we get C equals 74.21 degrees. This is possibility number 1. Now, is there a possibility number 2? Let's check. How we're going to check this is by subtracting the result from 180. 180 minus 74.21 equals 105.79. But how can we check if this is valid? What we're going to do is to get the result and add it by the angle given, which is 60, and And if it is less than 180, then it would be valid. But if it is greater than or equal to 180, then it will become invalid. So since 165.79 is less than 180, then it is valid. And 105.79 is a possibility number 2. So now we're just going to erase everything here. We're going to leave possible solution number 2 for later, and let's first focus on possible solution number 1. Sine B over D and find 74.21 over 10. We're going to now look for angle B, and how we're going to do that is by adding 60 and 74.20. 134 and subtracting it by 180 equals 45.79. Angle B is equal to 45.79 degrees. $45.79, and now we're just going to look for side B, and how we're going to find it is by cross multiplying these two. In a result, if you look in the calculator, it will say 77.44908. Round it off, we get B equals 7.45. So now we're done with the first possible solution, and we can say for sure that this results to an acute triangle. Now let's try solving for possible solution number 2. Sine 60 over 9 equals sine B over B equals sine 105.79 over 10. Add 105.79 plus 60, and we get 97561 minus it by 180, and we get 1, 2, 4, 14.21. So our angle B is 14.21 degrees. Multiply everything space 14.21, and then now we're just going to cross multiply 10 multiplied by sine 14.21 over sine 105.79, which if you calculate in a calculator, it will say 2.55106, round it off by the nearest hundreds, and we get side B is 2.55 inches. So now we are with solving both of the and we can clearly say that this possible solution number 2 results to a obtuse triangle. Thank you so much for listening, and I hope by this time you can learn how to solve for law of sines.